And this is in section 6.4, method of sections. Section 6.4 of the book. I really recommend for all these that you're also using the book. So the method of sections can be helpful. So with the method of joints, we can do a lot of this force analysis, but it's sort of tedious because you have to go to each point in the truss just one by one. The method of sections can make your life a little bit easier. This is especially helpful whenever you just need a couple of the forces and a couple of the members if you don't need all of them. So the steps for this. So the first step, decide how you need to cut the truss. This is based on where you need to determine the forces. So if the problem tells you that you need to figure out, or you need to know these three forces, see if you can make a cut through those. But then you have to also make sure that the total number of unknowns doesn't exceed 3. So you may need to do a cut somewhere where you didn't really want to just because you only have the 3 unknowns, and then you may do the method of joints for the next one. For the second step, decide which side of the cut truss will be easier to work with. So the goal is to minimize the number of external reactions. So you have to decide which side of the cut truss you want to work with. Basically with this, let me add a photo. So with this we have, you can see that well. So we have this truss, we have the reaction forces happening at the end. We'll probably do similarly where we'll look at the whole truss, do a free body diagram, and figure out what's happening here. So here we have 2 forces at D, and then at E we have a force for the roller just horizontally. So we'll do that to figure out the reaction forces. And then we do the method of sections. So say we're just interested in some of these, so we cut our section here. Then we can we need to decide which side we want to deal with. If you've already done this analysis over on the right side with the reaction, then maybe that side's okay. If not, it looks like the one on the left may have been easier because you know more of what's going on. So you want to minimize the number of external reactions that you have. So once you make the cut, and that's what this is showing you here, basically, so if we looked at the left side, we make the cut, and then we have to represent each of the cuts with forces. So we have that FBC from where we cut, the FG to C, and then the FG to F. So those are the 3 unknowns, and then we know that. Whereas if we had made the cut and looked at the other side, then we have to replace each of these. So FGF, FGC, and then FBC. And then we also have this DY, DX, and EX. So unless you've done that initial analysis, we wouldn't have known any of the stuff that's going on here, which would have made it harder. But once you know those, then you can figure out these. So you just have to figure that out. So it really actually makes a little more sense to go ahead and do the cut, figure out what you need to know. Because like for this one, we would have been okay without doing those support reactions if we didn't need them. But sometimes you'll find that you actually do need those. So in those cases, you'll want to determine any necessary support reactions by drawing a free body diagram of the entire truss and applying the equations of equilibrium. So some of the forces equal in the x direction equals 0, y direction equals 0, and some of the moments about p equals 0. And so then, once you do that, then we can use basically those equations of equilibrium to solve for all the unknown forces. And once we know that, then we can do either of these. So that's the method of sections. I believe that's all the content I want to cover for this section. I know it was a bit long. Actually, I'm sorry. I didn't write it down, but I'm going to write down the next step for this, or the next 2 steps. So I'll pause it and write it. So step 4, which is what I just talked about, you draw a free body diagram of that selected part of the cut truss and indicate any unknown forces at the cut members. So since you're cutting it, you'll have forces at each of those. And then for this, you can also just always assume that the members are in tension. And so when they're in tension, it's basically the forces away from the joint. And then if the answer is positive, then the member's in tension. If it's negative, then it would be in compression. Or if you want to, you can also decide if they'll be in tension or compression by inspection, which is what I had done for those other figures. And then the last step is to apply those equations of equilibrium. And so we basically have the three different equations of equilibrium. To that selected cut section of the truss, and then solve for the unknowns. So those are the sum of the forces in the x equals 0, sum of forces in the y equals 0, and sum of the moments about a p equal, or a point equals 0. A lot of times if you sort of look closely, you can see that you can write one of the equations just to solve for one unknown right away. So it looks like in this one we could do sum of the forces if we use that left side of the cut, so this one here. We could just sum the forces in the y direction equal to 0, because we know the 1,000 newtons. And then the only other one that has a y component is at FGC, then we'd be able to find FGC. And it's always good to figure out a sort of a smarter way to do things. All right, so now that's it for this section. This is section 6.1 to 6.4 on trusses.